The terrifying part. Nobody can guarantee the new system will hold when the next surge comes. And climate science says the next surge will come. It's not a question of if anymore. It's a question of when and how severe. The cause of the lake's dramatic rise isn't a mystery or a secret. It's measurable. It's tracked by scientists. It's real. Between 2013 and 2020, Lake Michigan experienced unprecedented precipitation patterns. The Great Lakes region saw more rainfall and snowmelt flowing into the system than it had in decades. Most of this came from somewhere unexpected. Some was natural variability, a normal fluctuation in weather patterns that cycles through the region over decades. But a significant portion came from something else, a climate system that was warming up and holding more moisture. Here's the basic climate science explained simply so anyone can understand it. A warmer atmosphere can hold about 7% more moisture for every degree Celsius of warming. This is basic physics that meteorologists have understood for decades. This means that when it rains, it doesn't just rain a little harder, it rains a lot harder. When snow melts in spring, it doesn't just melt normally over months. It melts all at once, creating massive runoff in a compressed time frame. The Great Lakes Basin saw all of this compressed into a period that surprised even the climate scientists studying it. The precipitation records showed patterns that were outside historical norms. The data told a story that was impossible to ignore. Scientists studying the phenomenon found something deeply disturbing. The variability is getting worse. Lake levels aren't just rising gradually anymore, like they might in a natural fluctuation that cycles back and forth. They spike, they crash. They create the conditions for what used to be called 100-year floods and 100-year storms to happen every few years instead of every 100 years. This is what happens when you warm the planet and add more energy to the water cycle. The system becomes more volatile and unstable. The extremes become more frequent and more severe. The comfortable predictability of historical weather patterns disappears. Cities that planned based on what happened in the past are completely unprepared for the future. The research is conclusive and deeply concerning. Over the next 3 decades, Great Lakes water levels are projected to rise another 7.5 to 17 inches on average. That's enough to push the current crisis further inland, to submerge more beaches, to demand even more protection infrastructure. At the extreme end, the high-impact scenario that climate models suggest is plausible based on current emissions trends, Lake Michigan could see up to 80 centimeters more water. That's more than 2.5 feet. Additional, on top of what's already there, on top of the flooding and erosion, the city just spent $500 million trying to fix. But here's what they didn't emphasize in the official reports and what most people don't understand. Even if the average water level stays the same, the storms will be worse. The surges will be more dramatic. The combination of higher baseline water with more extreme storm events will push the shore backward faster than any time in recorded history. A storm that would have caused moderate damage in 2010 becomes a catastrophe in 2030. The frequency of destructive events multiplies. What happened once in a century starts happening every 10 years. And the city's infrastructure, built for historical conditions, breaks under the new normal. The impact on Chicago's neighborhoods is already visible if you know where to look and what you're looking for. In Edgewater, beaches that existed for decades are now narrower. The soft sand is gone, replaced by hard-packed erosion damage and exposed bluff faces where the earth has been carved away by relentless waves. Residents talk about landmarks, a particular tree, a familiar rock formation, a distinctive beach access point that have simply vanished into the water. In Rogers Park, you can stand at the shore now and see pockets of land that dropped 15 feet during single storm events. You can walk to places that used to be completely inaccessible because they're now beach instead of bluff. The geography has literally changed. The psychological impact is hard to overstate. residents watch their community literally crumble.